Hi there, my name is Bob Plankers, and it is my pleasure to demonstrate how to create and configure key providers within VMware Cloud Foundation and VMware vSphere. While I'll talk about the standard key provider and the native key provider in this demonstration, I'll focus mostly on the native key provider. Key providers are a very fundamental component of enabling data at rest protections, things like VM encryption and vSAN data at rest protection, or the on-disk encryption component there. In turn, those enable features like the Virtual Trusted Platform Module, or vTPM. To see a demonstration of those features being enabled and operated, see the corresponding videos we've produced about them, please. Okay, so to start, we'll log into the vSphere client for the vCenter that we want to configure. Key providers are configured on a per vCenter basis for the hosts that are directly connected to that vCenter server. If you've got a linked mode configuration, you'll need to visit each vCenter separately. You'll also have to get to vCenter using its proper, fully qualified domain name and not an IP address. Both forward and reverse DNS, A and PTR records are required for VMware Cloud Foundation and for VMware vSphere components. This demonstration is in a simple environment. It's configured with 4 hosts, vCenter, and it's got vMotion, DRS, HA, and vSAN enabled. But you don't need those enabled or turned on in any way to configure the key provider. To configure a key provider, we will select the vCenter server object from the inventory view. Then we'll select the Configure tab, and then we'll select Key Providers. As you can see, no items found. There's nothing configured, so let's fix that. We click Add. We have 2 choices, Native Key Provider, which we'll talk about in just a second, and Standard Key Provider. The Standard Key Provider enables connectivity to an external key management server, or a KMS, somewhere else in your organization. To configure a Standard Key Provider to access a KMS, and hopefully a KMS cluster, you'd go ahead and add it. Then you need to give it a name, so we'll just give it a sample name like org KMS1. Most KMS clusters are 3 or more hosts, so we would say something like org kms1.a.cotr.org. Depending on your organization, you'd set these values, both the DNS entries and the address itself. This helps prevent dependency loops in case DNS resolvers aren't available when the environment's trying to boot back up again. So you'd configure the IP addresses, and then port 5696 is the standard KMIP, or Key Management Interchange Protocol, TCP port, and you configure that as well. This process varies from KMS to KMS, and definitely varies based on your organization's setup of the KMS and how you've got that deployed. It's best to follow the procedure documented by your KMS vendor in order to establish trust between the KMS and VCF. As such, I'm not going to go any further here, but you get a sense of how this is done. When it's properly configured, vCenter will use the nodes you've configured here in a round-robin fashion. There's not a concept of priority. It will also test them periodically for health. In case one is down, you'll get an alarm in vCenter server. The ESXi hosts in a cluster will keep encryption keys for VMs that are encrypted virtual machines. Their encryption keys will be stored in memory in that cluster. So short outages of the KMS will be tolerated. Not a problem. You can patch your KMS, and we encourage you to do that. It is a dependency, though. The KMS does need to be online first if you experience an incident like a power outage or some other incident that would take everything out. Okay, so that's the standard key provider. Let's talk about the native key provider. A native key provider is where VCF and vSphere supply keys for itself. To prevent dependency loops, the native key provider will store data in the cluster hosts as well as on vCenter. And so while this is convenient, it does mean that physical security of the host is a consideration. It also helps explain why we support multiple types of key providers. Different organizations have differing security needs, and so we've got multiple choices to suit whatever you need to build. So to configure the native key provider, we give it a name. Because you can export and import this configuration, such as to your disaster recovery site, I suggest giving it a name that won't have a name collision in the future. For example, you probably don't want to name all of your native key provider instances NKP. That's probably a bad idea. I like to name mine after the site or after the vCenter. So in this case, we'll just call it vCenter 8.1, and that's easy. Native key provider automatically uses a hardware trusted platform module, or TPM, for security if your hosts have them and have them enabled. If all your hosts have them enabled, you should check this box. It's a good idea. If all your hosts don't have it enabled and you check this box, only the hosts with TPMs would be able to participate. Maybe you want that, maybe not, but in most cases, most people don't want that to happen. So if not all of your hosts have TPMs, you can uncheck that. And keep in mind that ESXi will always opt for more security where it gets the chance to. So again, if you don't have this checked, but you have TPMs, it will use the TPM regardless of what you say here. So we can go ahead and say add key provider. Oh, and I should mention that if you choose poorly there and you decide later that you want to choose the other direction, you can delete the key provider and restore it again, and you'll get that choice. I'll show you that in just a minute. So it created it, but it says it's not backed up, and it has a warning there. We need to back it up before we can use it. So we go down below and we click back up. Now we get a choice. This is going to export a file to our desktop in order to for us to save it off to a secure location, a resilient location that we can find it if we need it later. We've got a choice. We can protect that file with a password, which is probably a good idea, or we can choose not to. As with all things security, there are trade-offs. If you don't have a password, then of course anybody can access that backup. But if you do set a password, then you, or more importantly, your whole organization, has to remember what that password is later if you need to use it. In this case, just to make it simple, I'm going to not use a password. No problem. So we back it up, and you can see it downloaded a file. That file is in my downloads directory, and I should do something. I should secure it as soon as I can. I mentioned before that you can do a restore. You can import a backup. And this is not just important for restoring service if there's a problem, but also if you're replicating encrypted virtual machines to a disaster recovery site, or you want to use vMotion or cross vCenter vMotion to move encrypted VMs around. All of those work great, but the key provider needs to be present on both the source and the destination. For a standard key provider, you would simply configure it in both locations, but for a native key provider, you need to log into the destination site, click Restore, find the backup file that you want to import, open it. I'm going to use one that I created yesterday. And I did not set a password there for ease of use, but you may have, and you would enter it here. And then you click Next. I mentioned that you would get this choice again, just for consistency's sake. I'm going to uncheck that, knowing, of course, that ESXi will choose more security whenever it can. And then I'll click Finish. Now we have two of them. A couple of things to note. One, we'll get a note up here. Multiple native key providers are configured. We support up to 32 key providers configured in a vCenter server in general. It can be a mix of all types of key providers. And so multiple native key providers are totally supported. The other thing, too, is we need to back up this key provider before we can use it. Same rules as creating a new one. So we'll go ahead and use the same process, and we get a download there as well. Now, if we want to, we can go ahead and use this. And to do that, I'll just demonstrate adding a vTPM. A virtual TPM helps secure workloads. It's a common requirement now for modern Windows operating systems. And so when you have a key provider configured, you can go into Edit Settings. And what you will see under Add New Device, the Trusted Platform Module option is here. If you don't see that, check to make sure you've backed up your key provider, and check to make sure that your choices about TPM hosts with TPMs is a correct one for your environment. Those are two major things that would affect whether this shows up or not. In my case, everything is good, so we can go ahead and add it. We see security devices, TPM. We can go ahead and say OK. And then you'll see the summary change to encryption from not encrypted to encrypted with native key provider, and then it names which one it is, so you can tell which one it's using. You can rekey these if you need to in the future. You can rekey them between the different key providers using the API. Enabling encryption, VM encryption and vTPMs, the workload has to be off the first time. But beyond that, you can do most operations live. So that's the key provider. I hope you enjoyed this, and I hope you learned something. Thank you very much, and check out our other materials around key providers and on-disk encryption. Thank you very much.